Today, we're going to look at word problems with integers. Let's look at the first problem. Express each sentence as a single numerical expression. Then, use the order of operations to simplify the expression. Subtract 7 from 10, multiply this difference by 2, square this product. So first, I'm going to look for some keywords. We have subtract, which is a keyword for subtraction. 7 from 10. Now, from is one of our turnaround words. So from and the word than both tell us to switch the order around. So we're going to start with 10 minus 7. If we look at the next part, it says multiply. So I know that means times or multiply this difference. So difference is the answer to a subtraction problem. So they're telling me that I'm going to take that subtraction, that 10 minus 7, and I'm going to multiply whatever my answer was by 2. So I'm going to write times 2. Then if I look at the next part, they tell me to square this product. So square is telling me that I'm going to have an exponent of 2. But this product is an answer to a multiplication problem. So that means I need to take this whole thing, that multiplication, and square it. So this, with the brackets, or I could have used another set of parentheses, and then parentheses 10 minus 7 times 2, that whole thing squared, answers the first part of this question. I express the sentence as a single numerical expression. Now I have to use the order of operations to simplify it. So for the order of operations, I use PEMDAS, or the acronym Please Excuse My Dear Aunt Sally, to help simplify a problem. P stands for parentheses, and with parentheses, I work from the inside out. So in this case, because I have two sets of parentheses or grouping symbols, I have these brackets and these parentheses. The parentheses are the innermost set, so I'm going to work there first. I'll do that 10 minus 7, which gives me 3. Now I'm going to bring down everything else so I don't forget about it. Now I'm actually not done that first step though, right? P was for parentheses or for grouping symbols. This 3 times 2 is still inside those brackets. It's inside those grouping symbols, so I need to do that multiplication. 3 times 2 gives me 6. And now all I have left is those grouping symbols and that exponent of 2. And that E stands for exponents. So 6 squared, you could plug in your calculator, or we know it means 6 times 6, which gives us 36 for our final answer. Let's look at another word problem. It says the peak of a mountain is 21,345 feet above sea level. The floor of a valley is 537 feet below sea level. What is the difference in elevation between the peak of the mountain and the floor of the valley? So if I picture what's going on, I have a mountain and then I have a valley. And we'll kind of picture this even right where they are, break even, as that sea level. And we usually count sea level as 0. So they're telling me this peak of the mountain is 21,345 feet above sea level. So because it's above, it's a positive number. And that the floor of the valley is 537 feet below sea level. So this right here is 537 feet below sea level. That below is telling me it's a negative number. And then they're asking me to find the difference in elevation. So remember, difference is a key word for subtraction. So if I'm writing this as an expression, it would be that 21,345 minus negative 537. I'm subtracting the elevation of the mountain minus the elevation of that valley floor. Now you can type that right in the calculator, but some students get a little mixed up with those double signs. So remember, if you don't like those double signs, you can use keep, change, change, and keep that first number positive, and change that subtraction into addition, and change that negative number into a positive number. When we do that, we're going to end up with 21,882 feet as the difference in elevation. Be careful to include units in your final answer. Let's look at another example that's taken from your textbook. So from our textbook, it says life expectancy for the average American man is 75.2 years. For a woman, it's 80.4 years. The number line in figure 5.5, with points representing 8 integers, indicates factors, many within our control, that can stretch or shrink one's probable lifespan. And then they give us this number line with those little kind of talk bubbles pointing to things. So for example, this smoke cigarettes is pointing to negative 15. So that's telling us if we smoke cigarettes, we'll be knocking 15 years off our lifespan. This positive 10 says have a blood relative 95 or older. So if we have a blood relative 95 years old or older, we can expect to live an additional 10 years. For number 3, they're asking, what is the difference in the lifespan between a person who regularly works puzzles and a person who gets less than 6 to 8 hours of sleep per night? So they're asking for difference again, so we know we're going to do subtraction, and we just leave that subtraction in the order that they give us this. So if we look at regularly works puzzles, that's the first group or first thing that they told us. If I look for that on my number line, it's here, right in between 4 and 6, so that tells me that it's 5. So that first number is going to be 5. And then the second thing they tell us is a person who gets less than 6 to 8 hours of sleep per night. So if I look for that, that's right here. It's in between our 0 and negative 2, which tells me it should be negative 1. So if I do that 5 minus negative 1, that's going to give me 6. The units were all years. So that tells us the difference in the lifespan between a person who regularly works puzzles and a person who gets less than 6 to 8 hours of sleep per night is 6 years. If we look at the next example, they ask us what is the difference in lifespan between a person who frequently feels stressed and a person who smokes cigarettes. So if we look for this frequently feels stressed, that is right here at negative 5 on our number line. They're once again asking for difference, so I use subtraction. And now I need to look for a person who smokes cigarettes, which was down here at negative 15. So I'm doing negative 5 minus negative 15. That gives me positive 10 years. So someone who frequently feels stressed can expect to live 10 years longer than someone who smokes cigarettes. If we look at this next example, it says that an automobile purchased for $52,000 is worth $39,850 9 years later. Assuming that the car's value steadily depreciated from year to year, what was it worth at the end of the 4th year? So this is a multi-step problem that we need to think through to make sure we really understand what's going on. So if I look at the information they give me, they tell me that we originally bought this automobile or this car for $52,000. So that's our starting price. But then they tell us that it's worth $39,850 9 years later. Then they also tell us that the car's value steadily depreciates from year to year. That means it goes down by the same amount every year. And they're asking us, what was it worth at the end of the 4th year? So this is what I really want, what it's worth at the end of the 4th year. Now, just from looking at it, I can't really figure that out. So what I'm going to do first is try to figure out how much it goes down by each year. The first thing I'm going to do that is I'm going to find out how much it went down by, so how much it decreased by over the 9 years, because that's the time period they gave me in the problem. So I'm going to take that $52,000 and I'm going to subtract out that $39,850. If I do that, that's going to give me $12,150. So every year, over 9 years, it went down by $12,150. The next thing I'm going to do is figure out how much it goes down by each year. So if this is how much it decreased by over 9 years, I'm going to take that $12,150 and divide it by 9. That tells me that we lost $1,350 per year on that automobile. But we don't care about how much it goes down each year. They asked us what was it worth at the end of the 4th year. So the next thing I'm going to do is figure out how much it decreases by over 4 years. So I'm going to take that $1,350 and I'm going to multiply it by 4. That tells me that it decreased by $5,400 per year. Now I can finally figure out what they asked me. They asked me what was it worth at the end of the 4th year. So I'm going to try to find out its value at the end of the 4th year. So I'm going to take that original amount. If we look back, that original amount was that $52,000. And I'm going to subtract out the $5,400 that it decreased by over, I wrote that wrong, the 4 years. And when we do that, we're going to find that it's worth $46,600 after 4 years. If we look at another example, it says Charlene decided to ride her bike from home to visit her friend Danny. 3 miles away from home, her bike got a flat tire, and she had to walk the remaining 2 miles to Danny's home. She could not repair the tire and had to walk all the way back home. How many more miles did Charlene walk than she rode? So I'm going to draw a picture to try to understand what's going on here. So we have Charlene, and she started at her house. So I'll put a C on it for it's her house. And she said that she rode her bike from her home to visit her friend Danny. So she's going to end up at Danny's house. Now it says 3 miles away from her home, her bike got a flat tire. So she went 3 miles biking. And she had to walk the remaining 2 miles. So my picture is not to scale, but I can still label it. So she walked the remaining 2 miles to Danny's home. She could not repair the tire and had to walk all the way back home. So in this direction, she walked the entire time. Then we want to know how many more miles did she walk than she rode. So the first thing I need to do is figure out how much she walked home. If she biked 3 miles there and walked 2 miles there, then I can just add them to figure out that she walked 5 miles home. So if I try to figure out the total amount she walked, I'm going to add the 5 miles that she walked home and the 2 miles from the way there and find out that she walked 7 miles. Now the issue is they're asking how many more miles did she walk than she rode. So we're comparing things here, right? We're comparing how much she's walking versus how much she's biking. So if I want to know how much more she walked, I need to do subtraction. So I'm going to take the 7 miles that she walked and I'm going to subtract out these 3 miles that she biked. And that tells me that there were 4 additional miles. So there were, or we could say that she walked 4 miles more than she rode her bike. Okay. Now if we look at another example here, we have a geometry application. So it's telling us to find the area of a rectangle with a length of 7 feet and a width of 9 feet. So I'm going to sketch out this rectangle. They told me that it was 7 feet by 9 feet. Now, you should already know, and if you don't, it's okay. You can study it so you know it for the test, that when we're talking about the area of a rectangle, it's the length times the width. So I'm going to do my 7 feet times the 9 feet. I'm going to multiply the numbers. So 7 times 9 gets me 63. And then when we multiply the units, the feet times the feet, it gives us square feet. Sometimes you'll see it written like that, and sometimes you'll see it written in words, square feet, or sometimes you'll see it written in words abbreviated, square feet. So any of those 3 answers is perfectly okay. As kind of a refresher when we're talking about geometry, if you're trying to find the perimeter, the units stay the same. So it would just be units, or if we think in terms of this problem, it would just be feet. And remember, perimeter is when you just add up all the sides. If we're talking about area, that's when you're going to end up with your units squared. So for example here, we had our square feet. And then we'll also look at volume. When we talk about volume, that's when we'll have our units cubed. So for example, it could look like feet cubed. So speaking of volume, let's find the volume of the box below. When we're talking about the volume of our box, the formula for our volume is the length times the width times the height. And in this case, right, this 3 would be the height. Our base is this rectangle that's 4 by 12, and then the height is how high up the box goes. So we'll have 4 times 12 times 3. When we multiply those numbers out, it gives us 144. Now notice this time there's no units like there were in our last problem. It doesn't say feet or meters or centimeters or anything like that. So I'll just write units cubed. If we were writing this out in words, we would write it as cubic units, and sometimes you'll see it abbreviated as CU for cubic units. So any of those three answers are correct.